Hello there. In this video we're going to talk about error conditions and how to handle them. When we talk about error conditions we need to distinguish these from bugs. Bugs are when the programmer makes mistakes in their code, which happens occasionally, and these mean that the program doesn't function correctly when it runs. An error condition can happen even if the code is perfect and doesn't contain any bugs, but it may encounter problems when it's run due to the environment that it's running in. So for example, if we want to read some data from a file but the file doesn't exist, that would be an example of an error condition. If we want to send some data over the network but the network connection is down so we can't send the data, again that's an error condition. We could get some data which is incorrect, full of gibberish, or maybe not in the correct format. We've seen earlier on in the course the kind of problems that can occur when we want to read data from the keyboard and the user doesn't type it in the format that we're expecting. So how do you cope with this? So far we've just taken the easy option and printed out a message and exited the program, which is fine if you're learning. If you're a professional programmer and people are paying money for you to write programs which are important to their business or their government or the hospital or whoever the customer is, then they will expect something rather better than that. One of the things they'll expect us to do is to communicate with the user. Tell the user that something has gone wrong, and if you can, try and give them some information which will help them to address the problem. So for example, they could retry. If the network data didn't get through, maybe there was just a glitch, and if you try again, maybe it'll get through this time. If there's some way they can try and fix things up, so for example, if the file we're reading from can't be found because the program's in the wrong folder, we could pop up a dialog box and the user can navigate around the file system and locate the file. Or the user may decide that the problem's not serious and they can carry on working as it is without having to do anything more, in which case they will just ignore the problem. We also need to think about who the end user is. It may not always be someone who's crouched over a terminal staring at the screen. It could be, for example, a network administrator. If the network's down, we may need to raise a support ticket so they can go and plug the cable back in or whatever the problem is. If we're working on a banking application, we may need to be able to contact the fraud investigation department if something unusual happens. So the important point is that we need to be able to pass on some information to the user. And there will also situations where the program may try to fix the problem itself. For example, if you can't reach a web server, you may wait a few seconds and then try again rather than having to wake the user up. When we're giving information to the user, make sure that you give information which is going to be useful to them. One thing that you see sometimes, especially with open source software, maybe not so much these days, but certainly a lot in the past, even with commercial software, error, then some code number occurred. Please consult the user manual. So this means you have to locate the user manual, maybe on your desktop or somewhere on the internet. In the old days you had to hunt around the office and it was probably hidden on someone's desk somewhere. And when you did find the error number, it probably wouldn't have anything useful. It may tell you to phone a number in the USA, or it might not even have anything at all. Or if you're looking on the internet, if you're using Google, you may find that someone's asked the question but no one's actually answered it. So that kind of error output is not very helpful. Another kind of output that I find not very helpful is the Java stack trace. Some of you may have seen this when a Java program crashes, or it could even be something on the web which is running as a Java application. It spews out this great long list of functions which means absolutely nothing. I suppose it might be useful to the developers as it tells them which function it crashed in and how it got there, but it's no help at all to people who are trying to work out why their program stopped working. So try and keep the information relevant and useful. There are times when you do need to exit the program if the program's got into a bad state and you can't do anything useful, or it may even be unsafe to continue. Then really you need to exit the program. But that's only something that you should do as a last resort. Okay, so we're going to put in all this code that communicates with the user. Where do we put this code? The obvious thing is to go to the function where the error condition occurs and put the code that communicates with the user in there, the error handling code, but that's probably not the best way to do that. The first point is that it's going to make the code more complicated. So for example, if you had some code that opens a file and reads the data in a loop, you're going to have to add some code that checks whether the file open succeeded, then do some error handling if it didn't, then process the user's response, and then when you're going through the loop, check each time whether anything went wrong, and again put some code in to interact with the user. So that's going to be quite a lot more complicated than it was before. And generally, the more code you have, the more likely there's going to be a bug somewhere. There's more things that can go wrong. Also, if someone has to work on your code and they haven't seen it before, the more code there is, the longer it takes them to read it and understand it, the greater the chance that they won't understand it properly and they'll make a mistake when they're editing it. So those are two good reasons to keep your code simple. The second problem is that the error handling code is not related to the code that surrounds it. So if, for example, we have a networking function and we suddenly put all this GUI code in the middle of it, that's quite a contextual jump for people who are working on it. The second drawback is that we have this code which may be, for example, handling networking, and then we introduce all this code which does user interface interactions. So that's quite a big contextual jump between different parts of the code. That does make it harder to read the code. You may find actually, if you're working in a large team, that someone who works on networking code is not really particularly strong on user interface code, and that people who are good at writing GUIs aren't really too hot on low-level networking code. So you may end up having to have two different people maintaining the same bit of code, which is, well, as we say in English, too many cooks spoil the broth. Too many chefs in the kitchen. The third drawback is that the code which handles errors in the program is spread all over the place. So you may find that you're writing the same or very similar code over and over again. And usually in programming, if you find that you're repeating yourself, that's usually a sign that you're not going about things in the right way. The other issue is that it makes maintenance more difficult. If you pop up a certain type of dialog box on an error and then you decide that you want to use a different type of dialog box, you have to go through every part of the code which uses that dialog box and change it. So that does make maintenance more difficult. So the best approach is to keep the error handling code together. This doesn't necessarily mean that all the error handling code has to be in the same place. For example, you could have some code which does user interaction in with the GUI user interface code, and the code which issues tickets or raises alerts in a different part of the code. But if you can keep related code together in its appropriate place, that's a better way of organising it. But this introduces a bit of a problem. We have an error which occurs deep down in the networking code, and we want the code high up in the user interface part of the program to be able to deal with it. So we need some way for the error to get from the networking code into the user interface code. The usual way for doing this is for the function where the error condition occurs to return. So the low-level networking function will return. If it's been called directly from the GUI code, then that can handle it, but it's more likely to have been called by some other function. So that function needs to return as well and pass the error on to this caller, and that will keep going until finally we return to a function that can handle the error. So how are we going to implement this? The way that C and early versions of C++ used to do this was by having the function return value correspond to some kind of error code. So if we imagine this is a little fragment of the function that opens the file, so we have a function called getData and it has some code which opens a file. Then it checks if the file is open. If the file wasn't open, it returns immediately, and the return value is some number that corresponds to the file not found error. If we imagine this is part of the code in the function that calls getData, so it calls getData here, it stores this return value, and then it looks at the return value to find out which error occurred. Because there's quite a lot of errors, usually we don't put if-else statements, we use a switch, which is a better way of handling this. So we'll do a switch on the value of the return code, and somewhere deep in this switch statement there'll be a case for the file not found, and then there'll be some code which does something suitable for that particular error. One point here is that these bits of code are in different functions. They could well be in different files, so we need to have some way to make sure that this value here is the same as this value here. So we need to do some kind of admin work to keep these things synchronized. Also, there's another point that when we return an error code, we can't use anything else in the return value. We've already used it up with the error code. And also the error code is just a number. All you get is a number saying what kinds of error happened. And then this code here has to work out what was going on. So there are actually quite a lot of maintenance problems that can arise from error codes. The first one is that you usually end up with a switch statement with lots of case labels. These can get difficult to work on once they take up more than the screen. Usually about 20 lines or so is the most that most people can comfortably work on. I once worked on a program which had a large switch statement in it. Then someone decided the switch statement has got so big so that they were going to start up a second one just for their own errors. Eventually people started using that switch statement for errors which weren't this person's error, and then eventually people got confused and started putting errors which belonged in one switch statement in the other, and then they got to the point where they were duplicating, so the same error was being handled twice. So that's really not something you want to happen. As we mentioned, the error codes need to be synchronized, so the variables need to have the same value in the called function and the caller, and that can be quite a lot of work just to maintain that. When we call a function which can return an error code, so every function that calls getData must check for the errors that getData can return. If it doesn't want to deal with a particular error itself, it must return it back to the caller, and then the caller has to deal with that error as well. So you can get this long chain of functions that need to handle errors. If a new error condition is added to a function, so we change getData and we add some more code that can create a new error condition, every function that calls getData has to be updated to check for this new error. Then finally, these values are all ints, so the compiler will be perfectly happy so long as that value is something that can be represented by an int. So we can put any number in there and the compiler won't complain. So if we return the wrong error code, or if we return a number that's not corresponding to any particular error code, then the compiler will pass it through, and then we find out when the code runs and we get strange error reports. So C++ added exceptions to address these problems. These came in the 98 standard, which was the first C++ standard. I think exceptions already existed in other languages, Ada, possibly some other languages before that, so C++ really borrowed them. So the basic idea is that when an error condition occurs, the program doesn't return an error code, instead it does something called throwing an exception. When this happens, the program will automatically jump into code that can handle the error condition. So this is all done by code that is inserted by the compiler and gets run at runtime. The programmer doesn't need to do anything. So the error condition occurs, the programmer says an exception needs to be thrown here. That's the only thing the programmer needs to do. And then the code inserted by the compiler will pick up this exception and automatically jump into code that can handle it. When it goes to this code, the code will be passed an exception object, so it's a bit like having a function which is passed arguments. This exception object is actually a full proper object, so it can have data members, and you can use these for storing useful information. For example, you could have the value of some variables at the time the error occurred, or you could put a nice little string in there that gives you a good useful error message. That's much better than having a number which just says what kind of error occurred. And also the handler depends on the type of the exception object, so these are objects, they have a different type for each exception. You can have a different exception for each error condition, or you could have one exception which covers a number of error conditions if they're all very similar. So the type of the exception will be checked by the compiler. The programmer doesn't need to put in a switch statement to do the routing manually. So the code will automatically route the exception object to the correct handler for the type of the exception object. The programmer doesn't need to write a big switch statement to do the routing themselves. We're going to be talking a bit more about exceptions in the next video, but let's sum up this one first. So when the program runs, error conditions can occur which are beyond the programmer's control. So these are basically problems the programmer encounters from the environment that it's running in, not from errors made by the programmer. These error conditions need to be resolved. Usually this involves communicating to the user in some way or another. When we write code which communicates with the user, it should probably not go in the place where the error condition occurs. We need to pass the error condition from the place where the function occurs to the place that handles it. We can do this by returning an error code to indicate the error condition, but there are quite a lot of drawbacks to that. So in C++, we usually use exceptions to handle error conditions. Okay, so we'll talk a bit more about exceptions next time, but meanwhile, keep coding.